So we have already finished with carbohydrates. Today we are starting with a new topic under this chapter biomolecules, that is proteins. Okay, now under this we have to study regarding some general information like how important is protein in our body, classification, then the structure, etc. Okay, now first I will just give you little information regarding proteins. So we all know that proteins play an important role in our body in the form of enzymes in all psychological reactions. Okay, so like all the physiological, not psychological, all the physiological reactions that take place in our body, and when protein behave as enzyme, they play an important role. Now we all know enzymes are those which are going to break up complex substances in our body. Okay, now this word protein, it is derived from a Greek word. Okay, it is derived from Greek word proteos. Now what is the meaning of this word proteos? Proteos means either you can say first, or primary, which also means first, or you can say the one which has prime importance. Okay, so protein is derived from a Greek word proteos, which means first, primary, or prime importance. Fine. Now where do you find these proteins? So proteins, you can say, they are present they are present in living cells, even in our skin, in our hair, muscles. Then you have your nerves, enzymes, antibodies, hormones, etc. Okay, now for this proteins I have prepared some notes, so I will be clicking the pictures and sending it to you all. So this video will only concentrate on the theory information, like whatever is required I'll write it out here, but it's not possible for me to write everything down. So whatever is important, I'll just mention it here. Okay, so where do you find proteins in our body? In the living cells, in our skin, in our hair, muscles. You have your nerves, enzymes, antibodies, and hormones. Okay, now from where do you get this protein? So basically we are talking about the source now. Okay, source means from the food from where you are going to get protein, or the protein rich food. First is, from milk we get it. Then peanuts म्हणजे शेंगदाणा. Okay, then you have eggs, under. Okay, you have fishes, you have pulses, you have cereals, cheese, etc. There are so many things from which you get your proteins. Right now, how are you going to define these proteins? Now proteins, they are going to be high molecular weight polymers of the monomer called alpha amino acids. Okay, proteins are high molecular weight polymers. Now polymers is what we are going to study in the next chapter. After biomolecules we are starting with polymers, so you'll understand that what are polymers. So basically, monomer means you are going to use a smaller unit. You are going to take two smaller units and you are going to combine it to get a polymer. Okay, so here it is a monomer of alpha amino acids. So your proteins, they are basically made up of alpha amino acids. Okay, now what are these alpha amino acids? Okay, what are alpha amino acids? Now when you take your proteins and when you hydrolyze it, it is going to give you a mixture of alpha amino acids. Okay, again I am repeating. When proteins hydrolysis undergo hydrolysis means what? Water. Okay, when protein and water comes in contact, it is going to give you mixture of your alpha amino acids. So basically you're going to take your proteins and water, that is hydrolysis, and it is going to give you n number of NH2 CHRCOOH. Okay, now this is called as the alpha amino acid. Okay, now why alpha amino acid? Can you see this NH2 group here? Okay, NH2, this is the amino functional group. Okay, and this COH group here is your acid group. That is why your alpha amino acid, both two functional groups are present in this, that is of amino group or the amine group and the carboxylic acid group. Now why alpha? Now if you look here, then this is one carbon atom which is attached to two different functional groups, but since there is only one carbon atom which is attached to this functional group, that is going to be alpha. Like what I mean to say is, if you have carbon here, okay, if you have OH group here, okay, so this is an alcohol group, right? Alcohol functional group. Now this carbon is attached to this functional group, hence this is going to be the alpha carbon atom. After you have one more carbon atom here, but this is second in line, so this is going to be beta. Okay, so this is how you are, that is why the name alpha amino acid. Fine, because these two functional groups are attached to only that one carbon atom there. Fine. Now next we move on to the classification of amino acids. Classification of amino acids. Now under this, now this is like, based on the groups that are attached to amino acids, then depending on like the acids that we take in, essential and the non-essential ones. So there are two types of classifications that we will be studying under this. Now first is the classification of amino acids based on the pH, that is whether it is going to be acidic, basic or neutral. Okay, so one is acidic, one is basic, and the other one is neutral. Okay, now like common sense, we all know something that is having acidic component is going to be acidic, the one which is having basic component is going to be basic, and this is somewhat we can relate to the definitions as well. So how are you going to define your acidic amino acids? Now in the previous textbook, like the previous batch textbook, uh, now the definition I'm going to give, that definition is there, and then I'll also give you the definition which is printed in your new textbook now. Okay, so like what they are saying is, if acid groups are more in number than amino group, then it is going to be acidic amino acids. Okay, if acidic groups are more than your basic groups. Okay, now what do I mean to say acidic group and basic group? Or better word, you can use it in place of acid, you can say carboxyl groups. Okay, no problem even if you say that. And in place of basic, you can even write amino, because amine is a base and carboxylic is going to be the acidic group, because there is proton there, H plus COOH, that H plus can be donated. Okay, so how will you define basic? More amino group and less, sorry, carboxyl group. Okay, so basically what I mean to say is, if you look at this amino acid, so if there is one more COOH group, then it is going to be acidic. If there is one more NH2 group, then it is going to be basic. And when it is going to be neutral, when both amino and carboxyl groups are equal. Okay, so this is one definition that is given in the previous textbook. Now I will give you the one which is given in your textbook for acidic, basic and neutral. Okay, so acidic you can say is, now if you look here, this R that is there, okay, in this place of R there can be any group. There can be a amine group, there can be a acidic group, or there can be a neutral functional group as well. Okay, so how are you going to define your acidic amino acids? Now you can say that if R has COOH group, then it is going to be acidic. Now one example I would like to give you is of aspartic acid. Okay, and its formula is COOH okay, now there might be some other group here, but of course it is not going to be a neutral or a basic group. Okay, that is why it is coming under the example of acidic. Okay, for basic, that R will be replaced by what? Your NH2 group, right? So here example is lysine, and if you look at the formula for lysine, okay, so you can see the basic group here. Okay, there is no COH group, that is why it is basic. Okay, and the last one is neutral. Neutral you can say is either you are going to have COOH and NH2 both in equal number, or you can have any neutral or no functional group at all. So here example I would like to give you is of alanine. However you want to pronounce it, you can pronounce it CH3. So if you look here, you need not have, or you do not have your acidic group nor your basic group, that is your amine group, hence it comes under neutral. I hope this is clear. Okay, now if you look at the naturally occurring alpha amino acids, now we have studied about glucose and we saw that glucose, the naturally occurring form was dextrorotatory. Okay, now alpha amino acid is levorotatory. Okay, it is levorotatory. What is the meaning of levorotatory? Like if you look at the structure of alpha amino acid, then it is like this. You have your COOH group, you have your H, you have your C here in the center, you have R, and you have your NH2 group here. Okay, now because NH2 group or your amine group is on left hand side, that is why your alpha amino acid is going to be levorotatory. Now this carbon here is a chiral carbon. Okay, chiral carbon. Now we have already done this. Now why it is called as chiral carbon? Because this particular carbon is attached to 1, 2, 3 and 4 different groups. That is why it is called as chiral carbon. I hope this much is clear to you all.